Hello, I'm Keith Witt. I'm a Biomedical Instrumentation 2 student at Cincinnati State. This is my partner, Jobin Carter. We're going to be talking about the Dash 400 monitor PM. Job, you want to tell us about the equipment that we're using?
Yes, this here is a GE monitor Dash 4000. It is a very common patient monitor. If you've ever been in the hospital, unfortunately, or had family members, you probably saw one very similar to it. It has a lot of features, can take a lot of readings. This other piece of equipment here is a safety analyzer. We'll be using it to do various safety tests on the monitor. This right here is a SpO2 simulator. It is basically the oxygen content in your blood. And here we have a blood pressure monitor simulator, which you're supposed to have maybe something better in the bottle, but we use what we can here to simulate an arm. And here's another patient simulator. It is going to be used for ECG and respirations per minute. The first part of any PM would be probably to get your items together and the paperwork. The paperwork, the PM sheet, is very self-explanatory. There's a lot of things you have to fill in, just the brand and the item number, things like that. Some of it's done for you on this one. But first off, on this monitor, the serial number is here on the back. It's down here on the bottom. You really can't miss this as serial number. And then your next thing you would do is a very simple visual inspection, which basically you look over the monitor a lot more in depth than I am right now. We've already done this one. And you look at all the cords. Just make sure obvious damage has not happened. Very simple things, but very, very important. And then your next thing you would do is to clean it thoroughly with the proper cleaning supplies, which we will go to in just a moment. As mentioned, one of the main first things you do on any PM is clean, which you may need these following supplies for. Some simple green cleaner or some other good cleaning product, and Goo Gone, because the #1 hassle of cleaning anything that I've ever PM'd is the sticker residue, which gets left on things. Thus, you may need a metal scraper or a plastic scraper, and you need good old towels and elbow grease. And now Keith is going to continue our PM with the actual technical items.
The first test that we do as far as the electrical safety test is to check the power cord resistance of any electrical or any medical device. This is important because it can indicate an unsafe condition for the operator of the unit. We want to make sure we're being safe as we're doing this PM. So we've got the electrical safety analyzer hooked up to a ground pin on the back of the unit. And we can see on here that our resistance is very low, about 1 milliohm, which is extremely good. The next test that we will do is we're going to test the chassis leakage. We're going to measure how much current is coming out of the unit that can also indicate an unsafe condition for the patient. So we change the electrical safety analyzer over to the ground conductance, and we open up ground, and we can see that we're getting 156 or 157 microamps of current, which will pass our test. The final bit of our test is to determine the amount of leakage. Current leakage is coming out to the patient via the patient cables. We're going to be testing all 3 of them at once. So we switch this over to the external leads. We have all of them selected, and we're going to open up the ground, and we see we have 0.07 or 0.7 microamps of current through each one of the leads.
The next part of the PM we're going to do is we're actually going to get in this monitor and do some things. First off, we need to turn it on. And we're making sure that everything, all the lights light up and the screen comes on, obviously, and everything like that. And here we go. All looks well. First off, before you start doing any measurements, you've got to make sure all your test cables are connected. They are color-coded, so it's very easy. You can't hardly mess it up. So first off, we'll do an SpO2 test with our simulator here. You got to make sure the light is lined up on the right side. It says light this side, LED this side. This is a Nel core lead, so we need to make our tester. It says Nel and mass. That's Nel core and mass mode. We need to make sure it's on the right setting before it will work. And our first test we're going to do is a 95% and 40 beats per minute. So we'll wait for the tester to come up here on the screen. It'll take a few seconds. Just wait patiently. And now Keith is going to take over the testing. He's going to do the ECG and the respirations for a minute. And we're going to switch places.
Thank you, Joby. The first thing we need to do is we need to hook the dash monitor up to the patient simulator. We're going to use these leads, the patient leads that we worked with, did the electrical safety test on earlier. These leads can come unplugged very easily, so we need to make sure they're plugged in nice and tightly. And we plug them into the tester according to the color code. Now the first test we're going to be doing on here is we're going to test the heart rate, the ECG pulse. So as you can see, we're starting to get some detection over here on the unit. You can see the QRS waveform that you've studied about. And we're starting to get a pickup here. We're sitting at 60 beats per minute. Joby, if you could record that. Then we're going to reduce our heart rate down to 30 beats per minute. And it'll take a little bit of time for it to pick up. You can see the peaks of the waveform are starting to spread out more, and it's reducing. And you can also see that we've got an alarm flashing here, and this is flashing red. The alarm reads bradycardia, which indicates a low heart rate condition. And we can see we're sitting at 29, 31. We're bouncing back and forth a little bit. Joby, if you could record 29. Then we're going to take the tester and bring it up to 80 beats per minute. We're going to see that waveform starting to pick up a little bit on our display, and that alarm should go away. It'll take just a second here for it to pick up. Now we're at 80 beats per minute on the unit, which is what we're outputting on our tester, and we have no alarm here. So we passed that test. Joby, if you could record 80. Then we're going to increase the heart rate up to 120 beats per minute. We're going to see that waveform showing up a lot more frequently now. And the dash monitor is displaying 120, so we've passed that test as well. And we're going to bump the tester over, and we're going to bump up to 240 beats per minute. We're going to see that heart rate showing up a lot more frequently now. 240 beats per minute should also set off a tachycardia alarm on the unit, which indicates high pressure. So we're going to see the number flashing here, and the tachycardia alarm show up on the screen. Joby, if you could record 240 and check the alarm box as well, please. That concludes the ECG portion of the test. We'll be using the same tester again, however, to test the respiration rate. So we switch the tester over to respiration rate, or respiration. Then we set it for rate, and we'll be doing 20 breaths per minute. And you can see the dash monitor has already picked up the 20 breaths per minute. Joby, if you could record 20. Then we'll set the tester to test to output 40 breaths per minute. And it'll take it a moment for the unit to pick up the respiration rate. We can see that it is increasing right now. And we have 40. Joby, if you could record 40. Then we're going to bump our tester up to 60 breaths per minute. And again, let this have a minute to record the correct value. Joby, if you could record 60. Then we're going to increase the rate to 120 breaths per minute. And we've got 120. Joby, if you could record that number, please. The final respiration test we're going to do is for apnea. Apnea is no breathing. You cut. We'll be doing an apnea test, which indicates a patient not breathing. We're going to set this to apnea, and continuous. And we should stop seeing detection of the breath and start seeing a straight line across here on the monitor. and the respiration rate will be dropping, and we should get an apnea alarm when it gets down below 10 or so. Just a couple moments from now, it should detect and throw up an alarm. And apnea. We got the alarm. Joby, if you could check that alarm box. And that concludes the respiration portion of the PM test.
And that concludes our PM procedure on the GE-4000 monitor. The last thing you do is just go over your paperwork, and as I did, I can see a few things that we forgot to mention. When you first turn the monitor on, there will be initial alarm, but for this production, we turned all the alarms off. And also, for same reasons, to make sure everything worked, you're supposed to do the whole PM on the battery, but we just ran on power to make sure we got a good video. And speaking of that, we would like to thank the audio-visual team here at Cincinnati State for the opportunity for them and us to film this production. And thanks a lot, guys.